Hi guys, hope you all doing well. So here in this video, we are going to analyze a standard MCQs on geometry, which are posted on our Community of CHEMMaster official YouTube channel and where you already have answers of each and every question. But here in this video, we are going to justify each and every answer with explanations. So that's why I hope it helpful for you and watch the video completely. Now just look at the first question. The correct statement of the following. Just look at the given four statements and we need to pick the correct one. So try to find the geometry of CCl4 here, where the carbon is a central atom. So we need to look at its valency electronic configuration. In its ground state, we can see Ns2, Np2. And in its first excited state, we can write Ns1, Np3. Now just fill the electrons in each orbital. Okay, right. 4 orbitals are with 1 electron each. Right. Now 4 chlorines are going to make sigma bond with 4 unpaired electrons of carbon. That's why here we can say that it is sp3 hybridized with 0 unpaired electrons. So, which leads to tetrahedral geometry. Now just look at arsenic molecule, where arsenic belongs to nitrogen family and which is having the valency electronic configuration as Ns2Np3. Now just fill the electrons, the orbital with 2 electrons, that is the paired electrons, and p orbitals with 1 electron each, right? And 3 chlorines can make 3 sigma bonds here. Now the extra chlorine is there with a negative charge. What we say? Cl minus, the chloride ligand, which is going to coordinate with the empty d orbital of this arsenic. Okay, Cl minus. So from this we can say that the hybridization is involving s orbital and 3 p orbitals and 1 d orbital, that is sp3d, right? sp3d hybridization with 1 lone pair electrons, which leads to distorted tetrahedral geometry. Okay, from this analysis we can conclude that second option is the correct answer. Okay, right. The next question. The geometry of P2s molecule is, here sulfur is considered as a central atom, and we know that sulfur belongs to oxygen family with valency electronic configuration as Ns2 Np4. Now just fill the electrons in orbitals here. So we have 2 unpaired electrons. You can see 2 unpaired electrons, right? These 2 unpaired electrons can make sigma bonds with 2p atoms, that is phosphorus atoms. We know that phosphorus is having Ns2 and Np3, that is s orbital is paired, and whereas p orbital is having 1 electron each. So 1 electron is used to make sigma bond with sulfur, and these 2 electrons of each phosphorus are going to make 2 bonds between 2 phosphorus atoms. Okay, so from this we can say that this is the correct geometry, so which is representing trigonal planar. So answer is trigonal planar. Most of the aspirants chosen bent, that is the wrong option. Okay, right. The next question. Which of the following has a square planar geometry? Now just look at the nickel complex here, where nickel is in +2 oxidation state. How can you find the oxidation state of the metal here? Simply consider nickel as X and chlorine is having -1 oxidation state. And how many chlorines are there? 4. And what is the total charge on the complex? That is a -2. So from that you can get X equals to +2. That is nickel is in +2 oxidation state. Okay, right. So when nickel is in +2 oxidation state, it has 8 d electrons, valency d electrons. Okay, right. And another most important point we need to consider, the chlorine is a weak field ligand. So weak field ligands cannot make the pairing of electrons. That's why here you can fill electrons as this. So simply the two unpaired electrons can be seen in the nickel tetrachloride complex. Whereas if the chlorine is replaced with CN ligand, okay, CN ligand, what happens? We know that CN is a strong field ligand. In that case, these two electrons paired up here, right? And the hybridization will be different. That is DSP. DSP3 hybridization can be seen, or DSP2, 3, 4, 2, 3, like that. Okay, right. Now for this weak field nickel complex, we can see here the four empty orbitals from S and P. Here they can be coordinated with four chlorine atoms. Okay, so simply it is sp3 hybridized. Okay, sp3 hybridized with 0 unpaired electrons, and that's why it is tetrahedral geometry. So here I'm just considering only sp3, that's why I said 0. Okay, right. Now just look at arsenic complex, where arsenic is belongs to nitrogen family with valence electronic configuration as ns2 np3, right? So just fill the electrons in each orbital. So s orbital is paired, whereas each p orbital with one electron, right? Now whereas in arsenic is in +1 oxidation state, by just losing one electron from here, okay, so it is having four unpaired electrons, and each is going to make sigma bond with fluorine atom, right? It is simply sp3 hybridized with 0 unpaired electrons. That's why it is tetrahedral geometry, right? The nickel complex is tetrahedral, whereas the arsenic molecule is also tetrahedral. Now just look at ICl4 minus. Okay, in that iodine is having the valence electronic configuration ns2 np5. Now just fill up the electrons here. So two electrons here, and only one unpaired electron can be seen. Now we can see empty d orbital in that iodine, right? Okay, now in the first excited state, what happens? This electron just moves here, right? And in this case you need to fill the electrons, right? Where the three chlorines can make three sigma bonds. Okay, so three chlorines can make three sigma bonds, and one Cl minus act as ligand, and which coordinate with the empty d orbital, right? And here you can see that the hybridization is sp3d2. You can see sp3d2 with two paired electrons, or two lone pairs. Okay, so sp3d2 with two lone pairs leads to square planar geometry, right? And now just look at if4 minus. So here you need to give the that means you need to look for the I plus electronic configuration, valence electronic configuration, and for that you can see two electrons here, right, and two electrons here, and its first excited state, one electron move here, then you can see one electron its d orbital, right? So three fluorine, here what we say, four chlorines can make a bond with sp3 dehybridization. Okay, so sp3 dehybridization with one lone pair electrons leads to what we say, CHEMMaster, or distorted tetrahedral geometry for IF4 plus. Okay, right. And the next question, oh sorry, wait, the electronic geometry of tellurium tetrafluoride and its hybridization is. So just look at the tellurium, which belongs to oxygen family with valence electronic configuration ns2 np4. So two electrons here and four electrons are filled up like this. Now in its first excited state, what you say, the electron from this p enter into empty d orbital, right? Now the 4 fluorines can make sigma bonds. Here you can see it is sp3d hybridized molecule with one lone pair electrons. Okay, so that's why here it should be trigonal bipyramidal with sp3d hybridization. Just look at the question carefully. Here it is mentioned that the electronic geometry, that means we need to consider electron pairs also in deciding the geometry of it. So the electron pair should be in equatorial position. In this case, you can see it is trigonal bipyramidal and with sp3d hybridization. And if you are given with shape of the molecule, then the shape is simply CHEMMaster. So when you have given with the simple word shape of the molecule or geometry of the molecule, then you can go with CHEMMaster without considering lone pairs. But if it is mentioned with electronic geometry or electronic shape, then you need to consider the lone pairs also in drawing that the geometry or shape of that molecule. So here for that electronic geometry of tellurium tetrafluoride is trigonal bipyramidal with sp3d hybridization. And if you like this video, please click on like, and if you are not subscribed yet, then do subscribe for more updates and more questions on community. And if you are interested, you can visit and join the CHEMMasters.online for the best concept oriented online courses. Thank you very much.